When you solve by graphing, you simply just graph the lines individually. And then once you've graphed the lines, where they cross is your answer. And so these particular lines are in slope-intercept form. If they're in a different form, standard form, you may want to graph by intercepts. But if it's in slope-intercept form, you want to graph that way. So you want to start at your y-intercept on the y-axis, and you want to move according to your slope. So the first one started at -7. So you're going to go to -7 on your y-axis. The slope was 3. Remember, when it's a whole number, it's 3/1. So you're going to go up 3 and over 1. And this is where you're going to graph your first line, up 3/1. You're going to graph that there, all right? The second line, you're going to start the second line at +1. +1. Now for this one, it goes -1 in front. So down 1/1, down 1/1. And so for this one, you can see that I almost crossed there. So what I can do if I see something that's close, I can take the second point and I can go up 3 and over 1 more. And you can see it would have gone exactly through that point. Even though when I just sketched it, it didn't go exactly through it. But you can see if you walk the line that it would have gone through that. And so you're welcome to walk it until you see where they cross. Because typically on these, I don't give you fractions. So if you're solving by graphing, I'm typically going to give you one that is going to cross right at something specific because I want you to have an easy way to find where it crosses. All right. And so for this one, you're going to cross at the point 2, -1. At the point 2, -1. And that would actually be your answer. 2, -1 would be your answer there. So for number 9, it said solve using substitution. I found that this was one of the harder ones on the quiz, even though it's already set up for substitution. And I think it's because you have y equals on both sides, like both of them have y equals something. And so when you have it, you just take what y is equal to and they're equal to each other. And so when you have something like this, you are going to take what y is equal to on the first equation, 4x minus 7, and you're going to set it equal to what y is equal to in the second equation, 2x plus 9. And then you're just going to solve. Remember, when you're solving these, all variables go to one side, all numbers go to the other side. And so for this one, we would subtract our 2x from both sides. We'll get 2x here, and that will cancel out there. We will add 7 to both sides. It will cancel here, and we will get 16 there. And then our final step is just to divide there. So x here is going to equal 8. You are not finished. Every one of these will have an x and a y answer, an x and a y answer. So once you have your x, you can plug it into either equation for x. And so if I plug it into the top one, I'll get y equals 4 times 8 minus 7. If I plug it into the bottom, I'll get y equals 2 times 8 plus 9. All right? Either way, when I do that, I will get my 25 as my y. And so my y is going to equal 25. And so my final answer here is going to be 825. 825. So for this one, they specifically said solve each system using elimination. Elimination is often called addition because that's what you're doing to your 2. But your goal here is that one of your variables eliminate. If you just add and nothing eliminates, you have to do something before you add. If you can look and say, okay, I see that I have a positive 1y and a negative 1y, you're ready to go. But if you don't see that, you're going to have to multiply one of the equations or maybe both of the equations to get something to eliminate. All right, this one was set up for you. And so you could go ahead and start adding here. Positive 4 and negative 3 give you positive 1. Positive 1 and negative 1 cancel. Positive 8 and 0 give you just 8. And so they were kind and you automatically solved there for 8. Once you know that x is 8, you are going to plug it back in to one of your equations. It doesn't matter which one. So 4 times 8 plus y equals 8. And then if I go ahead and solve that, I get 32 plus y equals 8. Subtract 32 from both sides. Pay attention to your positives and negatives here. Y is going to equal negative 24. And so my final answer is going to be 8, negative 24. So for number 17, it says your local cable television company offers 2 plans. Basic service with 1 movie channel for $35 or basic service with 2 movie channels for $45. What is the charge for the basic service and the charge for each movie channel? All right, each movie channel. All right, so for this one, you have to set up 2 equations, all right? It doesn't matter what variables you use as long as you tell me what it is. They're asking for basic service. So if I don't know that, I'm going to set up a variable for my basic service. And they want the charge for the movie channel. And if I don't know the movie channel, obviously, I'm going to have to set up a variable for that. So the first equation is going to be this first line right here. Basic with 1 movie is $35. So that is going to mean 1 basic and 1 movie is $35. The second equation is going to be that next line, basic service with 2 movies for $45. So I would say basic with 2 movies for $45, all right? For this one, I personally would solve by elimination here because that seems like the easiest one to me. You will have to multiply one of them by a negative number to get rid of one of your variables, right? And so if I just multiply this top one, every single piece by -1, then I'm going to eliminate something when I add. And so when I add this, I will have a positive b and a negative b, which will cancel. A -1 and a +2, which will give me a 1. And a -35 and a +45, which will give me 10. So I know that my movie channels cost $10 a piece. And then to solve for what my basic service is, I then can just plug it back in. So if my basic plus a movie is 35, then that means my basic is going to be 25. And so I'm going to say that my basic service is 25. And so this would be your answer here. So the only difference really between inequalities and equalities is what it's going to have a greater than or less than, okay? And the difference in graphing is you are going to graph the lines. You're going to determine if it's a dashed line or a solid, and then you're going to determine which way to shade. All right, but the final answer is going to be your shading, all right? And so for this one, they actually put it in slope-intercept form for us. So we're going to graph the line itself the exact way we did the first one. We're going to graph it the exact same way. So we will graph the first line here, starting with our y-intercept, +5. Our slope is 3, so we'd go up 3 and over 1, or we could go down 3 and left 1, all right? And then because it is or equal to, we are going to make this a solid line. So we're going to make this guy a solid line. Make him a little bit better there. So make this a solid line here. I'm still not doing it very well, am I? Might just draw it. All right. And then once you do that, you're going to decide where to shade it. So for this one, it says greater than. So you look at the y-axis here, and you see that it crosses at the 5. And so, well, that is not a very good line. Then you're going to decide if it's on the 5, where will I shade on this particular line if I want greater than? Well, y is greater in this direction. And I do it that way because sometimes when it's a stronger slope, it's hard to determine what's below and what's above and what's below. So just look at your y-axis. And so for this one, you're going to shade greater than, which happens to be on this side of the line. All right, so this would be greater than. And then I'm going to take my second line. This particular line starts at -2. And so I'm going to go to -2 on my y-axis. All right. And this also has a positive slope. Going to go up 1 over 1. All right, and it's going to look something like this. And you're going to see it's probably going to cross about there if I were to walk up 1 over 1 or down 1, left 1 here. This particular one is a dashed line. It's dashed because I do not have an or equal to. So when you don't have an or equal to, you are going to dash your line, all right? Now, this particular one is also greater than. And so for this one, I'm going to shade everything above this blue line here. And you'll notice that you create this particular wedge where they both cross each other. And so your answer is going to be this wedge right here. That will be your answer for this one. Now, I will tell you when I grade these, I grade the lines individually. Did you graph the first line correctly? Solid dashed, and is it correctly graphed? Second line, solid dashed and correctly graphed and shaded. And then your final answer shading. So these are kind of, I look at these in 3 parts. Did you do the lines correctly, and did you do the shading correctly for these?